Everyone, and welcome to lesson 26.4. This lesson is going to take place on your notes handout that is attached to Google Classroom or you should have received in class. Now, as a little warm up, we talked about first semester the idea of having a coordinate on a number line. So, for instance, if C is at -6 and point E is at 18, and if we wanted to put point D 1/4 of the distance from C to E, what we did was we thought about, okay, the whole distance here from -6 all the way to 18 is a total of 24 units. And we said, okay, if I'm only going to go 1/4 of that way, I'm only moving 6 units. So that's not my location, but I had to move 6 units from C to get to point D, which is actually at 0. Okay. That same idea is going to be really important to today when we are talking about directed line segments. Now, a directed line segment is a segment where order does matter. Think about when you are walking through our school. If you are starting in the math wing and you want to walk all the way to the field house, 1/4 of that distance might put you at, let's say, the media center. But if you were going from the field house to the math wing, 1/4 of that distance, starting at the field house, would put you maybe by the auditorium or the main gym. So there's a big difference with your starting location. That will be true with our directed line segments. It's not necessarily the same thing saying point D to point E because order is going to matter on this one since our starting location is going to matter. Okay. So, for instance, in this particular problem, we have Maria and Eric, and Maria wants to walk from her math classroom to the cafeteria. So, Maria is going to start at her math classroom, point M, and move towards the cafeteria. And again, the order does matter. So, Maria starts at -2, -1 is the location of her math class. And she's going to move then to the cafeteria, which is located at 2, 7. So what she's going to do is she is going to move 1/4 of that distance. Now, we can kind of assume that this is going to be closer to point M because 1/4 of the way, that's not even going halfway between the math classroom and the cafeteria. And again, the fractional distance we're going to be away from that first point is 1/4 of the way. So let's think about those 2 points in question. Okay, we are going to take point M, which was at -2, -1, and the second point again was at 2, 7. So to move from x value to x value, -2 to +2 is 4 units, and -1 to 7, we had to go a total of 8 units. Okay? So that would be the total distance move. But again, we only want to go a fraction of this way. So 1/4 of the way, 1/4 of 4 is 1, and 1/4 of 8, 8 times 1 divided by 4 is 2. So this is how much movement we actually have. We're taking -2, -1, our starting location, and we're adding 1 to the x values because that's the movement we actually moved, and 2 to the y values. So our final distance would be at -1, +1, which if we actually plot that -1, +1, that stopping location makes sense. Just looking at our picture, that looks about 1/4 of the way from M to C. Let's try another example. This time on this directed line segment from M to C, they're telling us not a fraction that we're moving, but a ratio. We are moving in the ratio of 3 to 2. So again, if you think about dividing this up 3 parts to 2 parts, what you're going to notice on here is 3 parts to 2 parts. It would probably be something like in the middle, or a little bit further than the middle, 3 parts to 2 parts, so that our point is probably a little bit closer to point C this time if we're trying to do 3 parts to 2 parts. Okay, so probably a little bit further along this time. That's just our guess though at this moment. Let's see how we actually find that. Now, when you're given a ratio problem, the top portion of your ratio to make it into a fraction is going to be that first value, in this case 3. The bottom of your ratio, though, is going to be the two numbers added together. So our total fractional distance we're going to use this time, since they didn't give us a fraction, they gave us a ratio, the conversion would be 3/5. Now, similar to the last problem, we want to look at those two distances between our starting point M and our ending point C that up above they told us was 1, 1 and 7, 6. Again, the X values, we had to add 6 units to get from 1 to 7. And for the Y values, we had to add 5 units to get from 1 to 6. So now, again, we want to think about how much did we actually move if we're only moving 3/5 of that distance. Well, the X values, if you multiply by 3/5, 6 times 3 divided by 5 is going to be about 3.6. And our Y values, if we moved 5, but we're only going 3/5 of the way, 5 times 3/5 is 3 units. So again, we're going to take that starting location of 1, 1, and we're adding to it 3.6 and 3, and instead we're going to be at 4.6, 4 is our location. And again, if we go back to kind of what we predicted, 4.6, 4 would put us up here on our graph, right around here, which is about where we guessed, 3 to 2 would be. Again, 3 parts versus the 2 parts from our point to C. Now, what happens, however, if we are going in a decreasing manner? So let's say this one, it says that we are going from B to C. So B is at 2, 0. C is at 6, -4. Okay, so again, we're decreasing this time. So notice, again, from B to C, X value-wise, we went to the right 4, but Y value-wise, we went down 4, right? We decreased to go from 0 to -4. So again, to that process doesn't change. We're going to take the +4 and multiply it by 1/2, aka divide by 2. We're going to take that Y distance moved and multiply it by 1/2. So that's -2. And our original starting point, 2, 0, we're going to add 2 since we went right, but we decreased 2 only. So our final point is going to be at 4, -2 instead, which again makes sense that that would lie about halfway through. All right, the last page has 2 more for you to try, okay? Both of these are dealing with ratios. So a reminder with the ratio, to get your fractional distance on each of these, the top piece of the fraction is going to be the first number listed. The denominator of your fraction are both pieces added together. So this one's asking you for 1/4 of the location from A to R. I really recommend plotting each time these 2 points. This time A is at 2, 0 and R is at 6, 4, so that you can see, kind of help visualize, okay, where do I think this is going to be closer to? And you know, to double check visually where your final point should be. Okay, you're also going to try that for part C. We will work more with these in class as well. Thanks, everyone.